So frequently, a relationship between two quantities is expressed as an equation in two variables. For example, y equals 7 minus 3x is an equation in x and y. So it is telling you that there's a relationship between x and y, and the relationship is that y is going to be 7 minus 3x. So you take the x, you multiply by 3, and then you subtract that amount from 7, and that's y. And equations can be represented geometrically on the Cartesian plane. And the way you do that is you plot all the points, all the order pairs that satisfy the equation. So you have an order pair x and y or a and b, and if it satisfies that equation, then that's going to be part of the graph. So then the graph consists of all the points whose coordinates x and y satisfy that equation. And the points that are part of the graph are often called solutions or solution points of the equation. Okay, so an order pair is going to be called a solution of that equation or a solution point of the equation in x and y if the equation is true when you substitute a for x and when you substitute b for y. So, as an easy example, the point 2, 1 is a solution or a solution point of this equation because when you plug in x equals 2 and y equals 1, when you replace the x and the y with these numbers, you get something that is true. If you get something that is true, that means that point is part of the graph and it is a solution. Okay, so the graph consists of all the points that are solutions of the equation. And if when you plug them in you get something that is false, then that point is not part of the graph. It is not a solution of the equation. Okay, so figuring out whether a point is part of the graph of an equation is actually really easy because, like in this example, all you have to do is plug them in and see whether you get something that is true or that is false. So let's do a couple of examples. For example, this one says determine whether the points A with coordinates 2, 13 and B with coordinates -1, -3 lie on the graph of y equals 10x minus 7. So we're going to figure out whether these 2 points are on this graph, on the graph of this equation. And all we have to do is plug them in. So let's check A. So we're going to plug in x equals 2, y equals 13. So let's see, is it true that 13, so I'm plugging them in here, 13 equals, so I don't know, equals 10 times 2, x is 2, minus 7. It is not obvious, but let's see, simplify a little bit. Is it true that 13 equals 2 times 10 is 20? 20 minus 7. Yes, this is true. So that means A is on the graph. Okay, so that means A is on the graph. And now let's do the same for B. Let's figure out whether B that has coordinates x equals -1 and y equals -3 is part of the graph. Let's see. So y equals -3, so we get -3. Is it true that -3 equals 10 times -1 minus 7? Well, it's not obvious, but if you simplify a little bit, this is -10 minus 7, and this left-hand side is -17, and that is not true. This is false. So what that means is that B is not on the graph. It is not on the graph. Okay, it is not a solution point and it is not on the graph. So being on the graph means again that when you plug in those values for x and the y, you get something that is true. Okay, if you got that, you should pause the video and attempt example 7 and see which of these 2 points lies on the graph, if any. Okay, now let's do it. So let's check A first of all. So that means x equals 1 and y equals 0. So let's plug it in there. Is it true? That's 0. So I'm plugging it in here, y 0. Phi equals 5 times 1 squared minus 5. And this one is actually pretty clear. I don't have to simplify this in order to see that it is actually true, because 1 squared is 1, 5 times 1 is 5, minus 5 is 0. This one is actually true. So that means that the point A is on the graph of that equation, okay? And now let's check B. B has coordinates x equals 2 and y equals 2. So is it true that when I plug in here 2 and 2, let's see, 2, is it true that 2 equals 5 times 2 squared minus 5? Well, that one is not so obvious, so I'm going to simplify it a little bit. So 5 times 4 minus 5. Okay, 5 times 4 is 20. 20 minus 5 is 15, so this one is false. So that means that B is not on the graph. B is not on the graph. Okay. Now, if you have an equation, there is a very basic technique that works for basically any graph. It's not the most convenient technique, but is one that works, that is universal, and it works all the time. It's labor intensive though, and this is the technique of plotting points. So if you have an equation, one technique for sketching the graph of that equation is the technique of plotting points. So basically, you make a little chart, a little table, and you make a table of values, x and y, and then so you assign values for x and figure out what the corresponding y is, or vice versa. Sometimes you can do it the other way around. And then you get the coordinates, and then you take all those points and you plot them. Then once you have enough to give you a good idea of what the graph is going to look like, you connect them, and that's your graph. Okay, is a sketch of the graph. It's not going to be like perfect, but it can be a good sketch, depending on the number of points that you have. The more points, the better and the more accurate the graph is going to be. Okay, so let's use that technique to sketch the graph of this equation. So sketch the graph of y equals 2x minus 5 by plotting points. Okay, I have here a table that has 1, 2, 3, 4, 5. So let's say we take 5 points starting from -4, -2. Let's go by 2s. 0, 2, and 4. These could be random numbers, okay? You don't have to go like by a specific difference. So use any numbers you want. I choose 2 negatives, 0, and 2 positive ones. All right. If x equals -4, and you plug that in there, that means 2 times -4, that's -8. -8 minus 5 is -13. So you see -13 is a little too big. So that means we should probably then, you should keep always, when you're sketching graphs, you should keep in mind your, the size of your graph paper. This one is a 10 by 10, so that's not good. So let's then choose smaller numbers. Let's say -2, -1, and maybe here, these ones should be all right. Okay, -2, if I plug in -2 times 4 times 2 is -4, -4 minus 5 is -9. So you get the point -2, -9, which is gonna fit because this graph is 10 by 10, okay? Okay, if you plug in -1, if you plug in -1 here, you're gonna get -2 minus 5, that's -7. So this is gonna be -1, -7. If you plug in 0, you're going to get -5. So you're going to get the point 0, -5, which we're going to plot. If you plug in 2, you're going to get 4 minus 1, which is 1. So you're going to get the point 2, 1, which is on the graph. And lastly, when you plug in 4, you get 8 minus 5, which is 3. So you're going to get the point 4, 3. So we have all these points. Now the idea is we plot them all and connect them and see what the graph of this is going to look like. So 2, -9, 2, sorry, -2, -9. -2, -9 is right here. Okay, so that's -2, -9. Then -1, -7. -1, -7 is right here. Then 0, -5 is right here. 0, -5. Then 2, when you plug in 2, you actually get -1. That's a little mistake there. When you plug in 2, you get -1. And then when you plug in, let's double check that one. When you plug in 4, you get, yeah, okay, just only that one. So 2, -1. So 2, -1. And then when you plug in 4, 1, 2, 3, 4, you get 3. 1, 2, 3. Okay. So you see, those are the points of our graph, and it looks like a line, and it is indeed a line. So wait a minute, 2, -1. Oops, this point I drew incorrectly. You see, this one should be 2, -1. That's right there. Okay, now it's good. So we connect them. And that's our line. Now, when you have an equation that is like this, that's gonna be the equation of a line. And if it's a line, you only actually need 2 points. You don't need that many points. With 2, you're good. And choosing not just any, well, you can always choose any 2 points. Any 2 random points will work. But there's 2 special points that make your life easier. When if you use those 2 points, then it's going to be even easier. And those 2 points are the so-called intercepts. That's for a line, okay? But you could talk about intercepts for any equation, for any graph. Okay, so what are the intercepts? The intercepts are just the points in the plane where the graph touches or crosses the axis, either of the axes, the x-axis or the y-axis. So if it crosses or touches the x-axis, it's going to be called an x-intercept. And if it touches or crosses the y-axis, it's going to be called y-intercept. Okay, at a point where the graph touches or crosses the x-axis, what is the y-coordinate? So if you have, what is the y-coordinate of that? The y-coordinate of that is 0. So that means this is the y-coordinate of that point is 0. And similarly, when you have the y-intercept, the x-coordinate of that is 0. Okay? So that means x-intercepts are going to be of the form x comma 0, and y-intercepts are going to be of the form 0 comma y. Okay, and keep in mind that intercepts are points in the plane and therefore must be written as ordered pairs because they are points in the plane. Okay, so when we find the x-intercept and the y-intercept, these 2 points are very useful for drawing a line. So suppose I want to graph this equation, which is the equation of a line. Let's find the intercepts and use those 2 points to draw the line. To find the x-intercept, well, the x-intercept is going to have y-coordinate equal to 0. So this is how you're going to do it. If you want to find an intercept, say the x-intercept, you're going to set the other variable equal to 0. So that means if I'm trying to find the x-intercept, I'm going to set y or plug in y equals 0. If I'm trying to find the y-intercept, then I'm going to set the other variable equal to 0. In other words, x equals 0. You're going to plug that in and find y. Okay, that's how you find any intercept. If you're finding the x-intercept, you set the other variable, which is y equal to 0. If you're going to find the y-intercept, you set the other variable, which is x equal to 0. Okay, so that means you plug that in the equation. So for the x-intercept, we're going to plug in y equals 0 in there. So we're going to get 0 plus 5 equals 1/5 x. And then, which is 5 equals 1/5 x. And remember that you get rid of that fraction by multiplying by 5 both sides. So you get that x equals 25. Okay, that's a big number. So we're going to have to just use a smaller scale here. Like go maybe by 5s or something like that. Okay, and then in this one, to find the y-intercept, we're going to plug in x equals 0. So that means we're going to get y plus 5 equals 1/5 times 0. That means y plus 5 equals 0, which means y equals -5. Okay, but x equals -5 means that the intercept is 25, 0. And in this one, y equals -5 really means that the y-intercept is 0, -5. Okay? And then we're going to use these 2 points, plot them, connect them, and that's our line. So because this number is pretty big, we're going to go by 5s. So let's say this is 5, 5, 10, 15, 20, 25. Let's say that's 25. So 25, 0. So we're going by 5s, okay? And then on the y-axis, we're going by 5s as well. So 0, -5 would be right here. Okay, and then we connect those, and that's our line. Again, you could use any 2 points that you want, but really the intercepts are the most some of the most convenient ones, okay? Because all you have to do is plug in 0 to one variable, solve it, which is really easy, and then do the same for the other one. Plug the other variable equal to 0, find the missing variable. So those 2 points are very special, very convenient, the intercepts. Okay, and that's a basic method for drawing lines. There's another method using the slope that we're going to talk about later, but that covers the basics on graphs and how to draw lines.